Would you know how to find the steepness of this x squared graph at this point, uno. Now, when I say steepness, mathematically, I mean the gradient. Now, to find the gradient of any curve is we need to find the gradient of the tangent to that curve. And a tangent is a straight line. Now, to draw a straight line, we cannot just use one point because I can draw an infinite number of lines through that point. However, if I have 2 points, there's only one line that I can draw. So I need to draw a tangent at this point, but there's only a single point. So what I'm going to do is approximate the tangent at this point by drawing another point here and connecting the dots. This we call a chord, and this chord is a decent approximation to this tangent. This point has an x-coordinate of 1. This point, what we say is that it's a distance h away from this point 1. So this x-coordinate would be 1 plus h. Now that we have the x-coordinate of this, we can now find the y-coordinate of this coordinate. So the x-coordinate is 1 plus h. The y-coordinate, y equals x squared. So whatever the x value is, we're going to square it. 1 plus h squared. To find the gradient of a line, all we do is the change in y over the change in x. So the gradient of the chord is the change in y, subtraction of y values. We're going to do this, take away this. So we're doing 1 plus h squared minus this y value is uno, divided by the change in x values, which we already know is h. Now we need to simplify this. We expand this bracket. 1 plus 2h plus h squared. You can write out this bracket twice. Minus 1 divided by h. Do you notice what happens on the numerator? The unos cancel. We are left with 2h plus h squared over h. Do you notice anything? They all have h. We can divide each term by h, and we are left with 2 plus h squared divided by h is just h, and this is just 1. So the general gradient of the chord is 2 plus h. Now remember, I put that point at a random place, and it was an approximation to this tangent. What I'm going to do is form better and better approximations of that by bringing this point closer to this one, because can you see? That chord is much closer to the tangent. But what do you notice is happening? The h value is getting smaller. So as I move this point closer and closer to this point, the h value is getting smaller. So what we're actually doing is we call it a limit as h gets smaller towards 0 of the gradient, of this gradient. As h tends to 0, it goes towards the value 2. Nice.